be looking at the properties of logarithms and how to use the properties of logarithms to condense logarithmic expressions. So when I say condense logarithmic expressions, what I mean is I want everything written as a single logarithm. This is an important algebraic skill to have, because if we're trying to solve a logarithmic equation, we need it written as a single logarithm before we can apply the vast majority of the tools that we would use in that situation. So we're going to look at a few examples, some of the potentially oddball examples, but we'll see what's going on. So let's say that we want to find the simplified version of 2 log base 3 of uv cubed minus log base 3 of uv. Okay, so we apply our properties of our properties of logarithms, starting off with the outside of the logarithmic expression. So we are going to have this become an exponent over here. And what that gives us is log base 3 of uv cubed squared minus log base 3 of uv. Now we can apply the difference. So the fact that we are subtracting logarithms, this means that we are subtracting exponents. And the only time we ever subtract exponents are when we are dealing with division. So what we have is uv cubed squared divided by uv. And now at the end we should simplify things down as much as we can. So let's look at that. Well, uv cubed squared, that is the same thing as u squared v to the sixth divided by uv. And then this can simplify down a little bit more to become log base 3 of just uv to the 5th. So this would be our final expression, as simplified as we can get it. Let's go ahead and look at a slightly more complicated example, but only slightly. Okay, let's say that we have the natural log, which is going to make our life a little bit easier because we don't have to write log base every time. But let's say we're looking at the natural log of x over x minus 1 plus the natural log of x plus 1 over x minus the natural log of x squared minus 1. Okay, so what do we have here? There's nothing on the outside of our logarithms, which means we don't have to apply that rule where we take the number from the outside of the logarithm and make it into an exponent. Instead, we're just going to go straight to the addition and subtraction, which we always take from left to right. So the first thing we're going to do is make this addition problem into a single logarithm. So that would be the natural log of, because when we add exponents, that means that we multiplied x over x minus 1 times x plus 1 over x. Fantastic. Minus the natural log. And sorry, my pen clipped there a second. Minus the natural log of x squared minus 1. Now, here we have a choice. We can either go ahead and get everything written as 1, or we can simplify down a little bit. And that's actually what I'm going to do here. Because if you notice, that x and that x will cancel each other out. And that leaves us with the natural log of x plus 1 divided by x minus 1 minus the natural log of x squared minus 1. Okay, now we are subtracting exponents. And since we are subtracting exponents, that means we divided whatever it was that we originally had. So the natural log of x plus 1 divided by x minus 1 divided by x squared minus 1. And now we just have to simplify down. So let's rewrite this as the natural log of x plus 1 divided by x minus 1 times x squared minus 1. We can do this because if we are dividing, we really multiply by the reciprocal. So we're dividing by x squared minus 1, we multiply by the reciprocal of 1 over x squared minus 1. Now, this is a difference of squares. And since this is a difference of squares, we can factor it out. And actually, we can factor it out very quickly. We would have x plus 1 in the numerator, and in the denominator we now have x minus 1, and I'm going to write that as squared, times x plus 1. And we see that this and this cancel each other out. So that leaves us with the natural log equals the natural log of 1 divided by x minus 1 squared. Okay. So essentially, what do we need to do each time? We need to apply the properties of logarithms. We need to apply the properties of logarithms. After we apply the properties of logarithms, we're done, other than some algebraic simplification. we need to apply these properties. So your options for remembering the properties are this. Either 1, memorize them, which I don't necessarily recommend, though it works out quite well. The second way is understand that logarithms are exponents. So apply the properties of logarithms to, or apply the properties of exponents to logarithms. Okay, that will do it for this video, and I will see you